This is section 8.6. We're going to look at this chart that has properties for every quadrilateral. So notice how we have properties listed and abbreviations for each shape. All sides are congruent. That works for a rhombus and every other type of rhombus, like a square. Both pairs of opposite sides congruent. That works for a parallelogram. So that means it also works for every other type of parallelogram. Both pairs of opposite sides parallel. That works for a parallelogram. So every other type of parallelogram as well. Exactly one pair of opposite sides parallel. That's your trapezoid. All angles are congruent. Works for a rectangle and every other type of rectangle. Exactly one pair of opposite angles are congruent. Kites have that. Parallelograms have both pairs of opposite angles congruent. Trapezoids don't have any. Diagonals are perpendicular. We know that works for a rhombus. It also works for every other type of rhombus, so square. Don't forget, kites also have perpendicular diagonals. Diagonals are congruent in a rectangle and every other type of rectangle. And diagonals are also congruent in your isosceles trapezoids. We'll kind of sneak that in there. That's cheating, I guess, a little bit. But diagonals bisect each other. That works for parallelograms and every other type of parallelogram. Okay, so this section, we're going to identify special quadrilaterals. It's basically using all the skills that we've had and just naming shapes with less stuff given. Okay, so here's a quadrilateral, ABCD. It has at least one pair of opposite angles congruent. What types of quadrilaterals? Doesn't look like we can even see what that says. What kind of quadrilaterals could this be? Is probably what it says. Okay, well, there's many possibilities. It could be a parallelogram and a rhombus, because you have opposite angles congruent there. It could be a rectangle and a square, because all the angles are congruent. Or it could even be a kite, because it has one pair of opposite angles congruent. So sometimes when you don't have enough info, you can't really say for sure what it is, but you can kind of rule some things out or make a better guess on what it could be. Here's a practice problem. What's the most specific name for this quadrilateral ABCD? Don't focus so much on what it looks like, focus on the markings. I see diagonals that bisect each other. Monty, take that packet, bud. You got videos to watch. Thank you. Okay, now if you have diagonals that bisect each other, that means this is a parallelogram. And it could be a more special type of parallelogram, like maybe it's a rhombus or a rectangle. Is there any other markings on there that would indicate that it's a more specific type of parallelogram? Do you see perpendicular diagonals, or congruent sides, or congruent angles, or congruent diagonals? With that information, the best we could do is say that it's a parallelogram. Could be something else, but we can't say for sure. Let's identify this quadrilateral. Is there enough information given in the diagram to show that this quadrilateral is an isosceles trapezoid? Let's explain. So since it's a quadrilateral, there's 360 degrees in the shape. We know that we have a 106-degree angle and we have two 74-degree angles. Grab a calculator. What's left over when you subtract there? It's going to be 106. So knowing that angle measure is important because now you can look at consecutive interior angles. If they add up to 180, then that forces these lines that make them to be parallel. Now, just because you have one pair of parallel sides doesn't mean it's a trapezoid. Maybe it's a parallelogram. Maybe the other sides are parallel as well. So let's take a look at those. What if we looked at this angle and this angle? Do they add up to 180? Okay, and they don't. So we know segment PQ and segment SR are not parallel. Okay, so it has exactly one pair of opposite sides parallel. That means it's definitely a trapezoid. Now, is there any way to prove that it's isosceles? Yeah, for sure. Look at your base angles. Are your base angles the same? Remember, we have acute base angles, and we also have obtuse base angles. Do they match? Yeah, they do. That's how you know it's an isosceles trapezoid. Let's identify quadrilateral DEFG. It has at least one pair of sides congruent. What types of quadrilaterals meet this condition? One pair of sides congruent, at least. So it could be a parallelogram. And if it could be a parallelogram, it could be that rectangle or rhombus. Both of those have at least one pair of sides congruent. Could be a square. So notice how I kind of did that in a shape that kind of looks like your family tree. Okay, well, it could also be your isosceles trapezoid. I'm using an abbreviation there, IT. Isosceles trapezoids have congruent legs. It could also be a kite. Kites have two pairs of sides congruent. Those are your options.